Alright, good day guys, how are you all doing? We're discussing the last term of calculation on binomial series, some little things that we need to understand on our binomial series. So before I break down some things, because literally the calculation that we want to move into much more now are basically based on the, what do they call it, the 1 plus x raised to power n. You're now breaking, if you haven't checked my video, go and check out my videos I did on binomial, you would understand better. Now, we want to look at some certain examples like, how do you find a root 4 plus x, let's say to the power of 3, that's x raised to power 3. How do you do that? And some other things like that. Now, let's look at any questions that involve this kind of aspect. Literally would refer you back to something like this. Are you getting what I'm saying? So, but before we break down something like this, let me just give you guys a little bit, a brief dem on what we call factorial. I've explained that before, but there's something that is very important I want to call you guys' attention to. I told you guys the other day when I said 5 factorial will be equals to 5 times 4 times 3 times 2 times 1. Like the rest like that also 4 and stuff. Now you would agree with me when I tell you that 5 factorial can also be breaking down as 5 into bracket 5 minus 1 factorial. How? If I'm to expand this one, what am I going to be having? I'll still have 5 times what? 4 factorial. And what would 4 factorial give me? 4 times 3 times 2 times what? Times 1. So at that point, I can easily break this down by saying that what? Since I have n factorial, I can say n factorial also signifies some certain particular aspect, which is n into bracket n minus 1, n minus 2. Then it continues like that. And if I don't want it to move on like that, I can use a factorial to what? To stop it. Are you getting what I'm saying? So, if you have to look at something like this, assuming you have been asked to expand something like this now, n minus 3 factorial. At this point, you have been asked to evaluate or break down something like this. How do you do it? You should know that we can easily expand this one and use it to break this one. How? N factorial now would be n into bracket n minus 1, then n minus 2, then n minus 3 factorial over n minus 3 factorial. Then this cancels out. You have what? Your answer is this. Are you getting what I'm saying? So this at this point is actually very important to break down while we are explaining some certain particular things under the binomial series expansion. Now let's assume you have been given something like, let's say you have something like negative 2 factorial. You should know that if you have been given something like negative 2 factorial, you would need to expand this. But let's say I give you negative 2 factorial over negative 3 factorial. And I say you should expand something like, break down something like this. In this point, you should not be able to follow that law, because you can't just point negative 2 factorial inside your calculator. It will give you math error. So at this point, you are going to be having negative 2 into bracket negative 2 minus 1. Don't forget the law. Factorial over what? Negative 3 factorial. And this will become what? Negative 2 into bracket negative 3 factorial over negative 3 factorial. This will cancel out this. You have what? Negative 2. So put this at the back of your mind. And from this point now, let's move into our basic dem of work. Let's assume you have been given a certain particular question. Let's say you have 1 over, you have a 4 minus x raised to power 2. Now if you have been asked to expand this to, let's say, the power of x raised to power 3, that's you having x raised to power 3, the power of x raised to power 3. Are you with me? So at this point now, you should know that you can't just directly utilize this question by expanding it. So you have to break it down into pieces. Are you with me? And how do you break it down? We want the particular equation to look much more like 1 plus s raised to power n, because that is much more like the easiest way to break this kind of dem down. So from law of indices, you would agree with me when I tell you that this can be equals to 4 minus x raised to power negative 2. Right? But of negative 2, which is still 1 over 4 minus x raised to power 2 back. Now, but before that, so as not to cause confusion, just note this down like this. Try to break down some certain particular thing. Now, from here, if you look at this, we want to make this equation looks like this first, before we now what? We now improvise the last law of indices. Now, from here, I could say that I have 1 over 4 into bracket 1 minus x over what? 4 raised to power what? Everything raised to power 2. Are you getting what I'm saying? 4 into bracket 1 minus x over 4, everything raised to power 2, because everything is inside what? This journey of raised to power 2. And if I'm to expand it back, what am I going to have? 4 times 1, 4. 4 times negative s over 4, I will have what? Negative s. Everything raised to power 2 back. Are you get what I'm saying? Now from there, now I can easily say that what? This could be equals to 1 over me having 4 squared, then into bracket 1 minus x over 4 raised to power what? 2. Are you with me? So from this point now, this could be equals to me having 1 over 16 into brackets 1 minus x over 4 raised to power 2. Now if you have to look at now, this is what I want to expand. This is my basic point I want to expand. And if you agree with me, if I'm to tell you that this can be broken down as 1 over 16, then times 1 over into brackets 1 minus x over 4. This is a constant number, just multiplying this expansion. This is what we want to expand much more to the power of what? 3. Like the s raised to power 3 to s raised to power 3. Now listen, there is a difference between telling you that expand it to third term and expand it when you give it the value. Okay, expand this to third term. That means the first one you can have n combination 0, n combination 2, n combination 0, n combination 1, n combination 2. That is 3 term, 1 to 3. When I tell you expand this with respect to the power, that let's say they said s raised to power 3, like I was saying now, you have to expand with respect to whatever the power of x will give you, which is 3. So that point I show that where we are going to start from would be 3 combination 1 and stuff like that. But let's still understand some certain things. Just what we are looking for is where x raised to power 3 would occur, and at that point we are going to stop there. Now before that, now you know this will be equals to 1 over 16, then into bracket, don't forget this one I can use indices law, 1 minus x over 4 raised to power negative, so this is negative, this is raised to power 2, sorry, raised to power 2, don't forget. So this will be equals to negative 2. Are you with me? So this is what our problem is. This is what we want to expand. And from here, just like the way I explained the other time for you guys, that law would be very, very important, or it will be actually utilized. So if you are to expand this now, we are going to be having this. Don't forget, we said to x raised to power 2. That is where we are stopping, negative 2. And what was our law for this particular important term? Now, actually, we know the law already is direct them, but let's take it step by step so as not to still cause confusion. Don't forget that at this point, we said that our r is actually greater than or equals to 0, starting from 0 upward, right? Now, from this point now, you should know that the loss distance n combination r for p raised to power what? N minus r and q raised to power r. That was our law, right? And at this point now, don't forget the n here is equals to negative 2. Please don't forget why our r starts from 0 upward. So let's break it down step by step. We ought to do it directly, but I want to break it down step by step first so that we can understand. Now let me put this on one side here. This is not the solution, but let me put it one side here. So now let's expand now. From here, you should know that the first thing, you are going to be having what? Negative 2 combination what? 0. And don't forget, let's list out. Let's say p is equals to 1 and our q is equals to what? Negative x over 4. Please don't forget that, it's very, very important. So from this point now, so as for the equation to look like p plus q, don't forget, raised to power n. Hope you are getting what I'm saying. And literally, it's just like we saying 1 plus q raised to power n. But just to make things clear, are you with me? So from there now, you have this. The next thing you have p raised to power n minus what? You have p raised to power n minus r, which means what is our n? Negative 2 minus what? 0. So I'm going to be having negative 2 minus 0. Are you with me? Then our q raised to power what? 1. Raised to power 0 rather. So r is equals to 0, then our value of r stands for, so q raised to power 0. Are you with me? So the next one plus, you have negative 2 combination 1, p raised to power negative 2 negative 1, q raised to power 1. Are you with me? Then, now if I were you, should know that the term at which you have s raised to power 3 would surely be the fourth term, because this will give us 1, this will give us x, the next one will give us x squared, the third one will give us s cubed. Are you with me? Which means we've gotten to whatever I want to do. So from this point now, this would be plus negative 2 combination 2, p raised to power negative 2 negative 2, q raised to power 2. Are you with me? Then plus, you have a negative 2 combination what? 3, p raised to power negative 2 negative 3. Are you getting what I'm saying? Then q raised to power what? 3. Like I said, this will give us s cube because at this point you have s power what? S power 3. So moving on to whatever we want to do from this point now. From this point, we have, let's break it down now. This will be equals to negative 2 combination 0. How do we do that? Now don't forget our law for combination. I think that n combination r will be equals to n factorial over n minus r factorial. Are you with me? I tell you guys that note that 0 factorial is equals to 1. 1 factorial is also equals to 1. It's good at the back of your mind, don't forget. So at this point, a negative 2 combination 0. You can't do this directly with your calculator. Why is that? There are some 1 or 2 issues that you might have, which is going to be giving you math error. So you have to apply the normal rule of the combination to it. Now you have negative 2, Abby. So that will be negative 2 factorial over negative 2 minus 1 or minus this one. Our r is 0. So negative 2 minus 0 factorial, right? Then p, what was our p? 1 raised power any here will still give you 1. And q raised power 0, n raised power 0 will still give you 1. So we are just left with this saying 1 times 1. Are you get what I'm saying? So plus the next thing now we have negative 2 combination 1. That will be what? Negative 2 factorial over negative 2 negative 1 factorial 1 factorial. Are you get what I'm saying? This will still give us, all of them here will be giving us 1. So let's just ignore it. This will give us 1. The p will surely, anything is 1 is for anything will still be 1. But I just want us to break it down. That was why I actually introduce it back, because we would have left only q there alone. But just for things to clear, or just for clarity. Now I know this will give us 1 back. So let's just put it there times 1. Then what is our q? Our q is negative x over 4. And that will be into brackets negative x over 4. Plus the next one, we have this. Negative 2 combination 2. You have negative 2 factorial into bracket negative 2 negative 2 factorial. Then you have what do they call it? 2 factorial, right? The law, don't forget. R factorial. So from there this will become 1 again times 1. Then times this will be what? X over 4 negative x. Please don't forget. Negative x over 4 squared. Are you with me? So from this point now, moving on to this point, we have plus. We've done this, right? So the last one now, you have plus into bracket negative 2 factorial over negative 2 negative 3 factorial, then 3 factorial. Are you with me? This thing gives us 1 also times 1. This is 1 also, don't forget. Times 1, then what will you have done times negative x over 4 raised power 3. From here you have basis power 3 already. You get what I'm saying? So at that point, you know this is our stopping point already, just like the way I stopped here. So this will be equals to, everything here will give us 1. We already know that. Now let's reconfirm. No, this will be negative 2 factorial. Negative 2 negative 0. You have negative 2 factorial. They will cancel out. 0 factorial is 1. So 1 times 1. Negative 2 factorial times 1. Negative 2 factorial. So negative 2 factorial will cancel out negative 2 factorial. So you have 1. 1 times everything will still give you 1. So plus, now if you look at this point here, now let's bring it out somewhere. Now if you look at this is negative 2 factorial, right? Over, don't forget, this negative factorial over negative 3 factorial. This 1 factorial will give us what? 1, so ignore it. Now this point, now look at, we can break this down as negative 2 times into bracket negative 2 negative 1 factorial. Don't forget what I just did in the previous them now. So this point, you know that this will be negative 3, and they will do what? They will cancel out themselves. That means you are going to be having what? Negative 2. And you know minus times plus, we change this plus to minus. So you are going to be having what? Negative 2. Are you get what I'm saying? So that will be negative 2 times what? Times 1. Are you get what I'm saying? Then times negative x over 4. And don't forget, from the breaking down, negative 2 times 1 will give us negative 2. Don't forget, the negative times negative will give us a positive. So that will be what now? But let's just put it down here so that we can move it to the next step. So that is this point here. Now the next one now we have this. This is negative 2 times this. So from the next point now, we are done with this part. The next point now, you have negative 2. You have negative 2 factorial over negative 4 factorial 2 factorial. Don't forget 2 factorial has a value. 2 factorial is just like saying 2 times 1. Don't forget. So this one you have to make sure we find a way to cancel out this. So this will be negative 2. You have negative 3. Don't forget my negative 2 minus 1. Then you have negative 4 factorial over negative 4 factorial. then 2 times 1, which will give us what? 2. So from this point, this will cancel out this. So we are going to be having negative 2 times negative 3. Are you with me? So that will give us what? That will give us what? 6 over 2, which will be equals to what? 3. Are you with me? So that means we are going to be having plus, everything here will give us 3. Plus 3 times 1 times, now negative x. So now I'm trying to break everything so that you can understand better. So at this point now, you have plus 3 times 1 times negative x. Don't forget there's a negative here, please. Don't put your mind at there. Negative times negative will give us positive. Then this will be x squared over what? 16. Are you with me? So the next one plus. So we've done the first, second, the third, and the last one, which is the fourth. So this one, as you know, this one will be breaking down to negative 2. Let's do this straight away. Negative 3, negative 4, negative 5 factorial over negative 5 factorial. And this will be 3 times 2 times 1. Don't forget, right? So this will cancel out this one. Then from the next, this one will give us positive. 4 times 3, 12. 12 times 2, you have what? 24 over 3 times 2, you have what? 6. Are you get what I'm saying? So you have 2 in this, you have 3. 2 in this, you have what? 12. Don't forget, then this will be equals to what? 4. So from that point now, you have plus. We have plus from this point now, you have plus. So this will give us 4. Then times 1 times. Don't forget, negative cube will give you negative back. You have negative s cube over 4 cube would give us 64. 64. So at that point now, if you are to proceed from here, I'm trying to break it down. Whenever you want to do this in your exam, make sure you are fast with time. Okay, so this will be equals to 1 minus times minus, you have plus. That will be plus 2x over 4. Are you with me? Then plus 3. 3 times this will give you what? 3 times 1, 3 times x squared. You have 3x squared over 16. Are you with me? Then plus, so 4 times 1, 4, 4 times negative. This one you have plus times, plus 4 times 1, 4, 4 times, plus times minus, you have negative 4s cubed over 64. Are you guys what I'm saying? So this is our expression for it, but let's just break some things down there. Let's do something down there. So that's 64 divided by so this, breaking this down, finally you have 1 plus 2 into 1. This will give you x over 2 plus, can 3 go in 16? So you have 3s squared over 16. Then negative x cubed over what? Over 16. Are you get what I'm saying? 4 in 4, 1, 4 in 64, you have 16. So this is our answer for the expression. So therefore now do not forget that the question is what? 1 over 4 minus x squared. So the answer we break down was 1 over 16, right? Into brackets 1 minus x over 4 raised to power negative 2. Are you with me? And this was what we expressed to get this. So our answer will be equals to 1 over 16 into brackets 1 plus x over 2 plus 3x squared over 16 minus s cubed over 16. So that is your final answer under this. So I hope you learned something. So anyhow, any question they give you, if they are something that is not straightforward, you find a way to break them down into 1 plus s raised to power n. So just like we were saying, so you have this. So this is your breaking down. Now if you look at, we made a little bit error at this point. That's the last term. The last term would give you negative times negative positive. Positive times negative, you have negative 4, not positive 4. Please know that. So that will become negative times negative, you have positive. So this will give us positive. Then you have positive. So please note that, okay? This plus 20, minus 24, not plus 24. So from there, the question might also ask you, like, this is your final answer already, we are done. But the question might ask you that prove the limit for which this particular thing you use exists. And don't forget, what do we use? We use 1 plus s raised to power n. And the law for 1 plus s raised to power n tells us that negative 1 has to be less than the s value and also less than what? 1. How do we know? From the function of x here, given that x is an absolute value, it has to be less than 1. Are you getting what I'm saying? So from this point now, if you are to look at the x value is also like correlating with this. Are you with me? So being an absolute value, we know absolute value of negative s over 4, which will still give us what? Should be less than 1. So if you want to prove this now, that the function is less than or literally equal to, is actually less than with respect to this formula. You know, absolute value will give us x over 4 is less than 1. Are you get what I'm saying? So at that point, you are going to be, if you cross multiply, you have x less than what? 4. So since x is actually less than 4, and at that point, you should know that what negative 4 will be less than x and also less than what? 4. So that is how to prove the limit for the particular then, if you have been asked to do that. So I hope you learned something under this expression. Alright, so at this point, let's look at another example under the binomial series, which refers this one. So at this point now, you know that we need to break it down. So you can have this as root 4 into bracket 1 plus x over 4. Don't forget, then this can break it down as root 4, then times root 1 plus x over 4. You know now, breaking down of surd law. So this will be equals to 2 into bracket 1 plus x over 4 raised to power 1 over 2. Law of indices. We are going to be expanding this one. So even having 1 plus x over 4 raised to power 1 over 2. The law, don't forget. Now this question, you are expanding it to the third term. So that means first, second, third. So from the law, you know this is actually respect. The first one will be 1 plus that's n combination 0. The next one will be n combination 1. Don't forget that's n combination 1. And I told you, literally, since 1 is useless, let's just ignore it. We are dealing with only this one directly. So the next one will be x over 4, you know, raised to power 1 plus n combination 2, then x over 4 raised to power 2. Agree? So this will be equals to 1 plus. Now what is our n? Our n is equals to 1 over 2, don't forget. So you can express it 1 over 2 factorial into bracket 1 over 2 minus 1 factorial. Are you get what I'm saying? Then 1 factorial x over 4 plus 1 over 2 factorial. Then you have 1 over 2 minus 2 factorial 2 factorial of x over 4 squared. Are you with me? So from this point you have this as 1 plus. Don't forget our law. This can be written as 1 over 2. Then 1 over 2 minus 1 factorial over 1 over 2 minus 1 factorial, then times 1. You know 1 is useless there. So let's just ignore it. Then x over 4. So this point you have 1 over 2, 1 over 2 minus 1, 1 over 2 minus 2 factorial over 1 over 2 minus 2 factorial. Then this will be times 2, because 2 factorial is 2 times 1, which is going to be 2. Then into bracket x squared over 16. So at this point, this will cancel out this. This will be equals to 1 plus. So you have 1 over 2 times x, right? And that will give us 1 over 2x divided by 4. Don't forget. So this is just like you saying x over 2 divided by 4. And that will be x over 2 times 1 over 4. Law of fraction. So that will be plus x over 8. You get what I'm saying? So the next one you have this. This will cancel out this one. So you have 1 over 2. This will be negative 1 over 2. That's 1 over 2 times negative 1 over 2. That will be negative 1 over 4. Are you see? Divided by 2. Don't forget divided by 2. So that will be negative 1 over 4 divided by 2. The same law. This one will come down. So that will be negative 1 over what? Over 8. So from this point, that's negative 1 over 8. So that will be negative 1 over 8 times x squared. And that will be negative 1 over 8 x squared divided by what? 16. So that will be negative x squared over 8 times 1 over 16. Do not forget. So at that point, 16 times 8, we have 128. So this will be equals to negative x squared over 128. So that is the breaking down of our expression. So at that point now, if you have to look at it, now the other one, you should know that the other one we're not able to break it down, because you can leave your answer like this. So we can express it now. You know, this is the final breakdown that we use this one to expand. So your answer will be equals to 2 into bracket 1 plus x over 8, then minus x squared over 128. So you can decide to make the answer like this as a final. But if it is an objective question, so whereby you couldn't find this, maybe they will actually expand it. So you will have to expand it also. So if you have to expand this now, this will be equals to 2 times 1, you have 2. No, this will be 2x over 4. 2 into 1, 2 in 8, you have 4. That will be x over 4 minus x squared over. So you have 2 in 128, that should give you 64. I'll give you 64. So this is our what? Our final answer for the expansion. So please like and please subscribe. So if you want to test for the limit for this one, it's still the same testing. So this is still x over 4. So it's still the same testing. You have x over 4 less than 1. So negative 4 will be less than x and also less than 4. Are you get what I'm saying? So it is still the same testing because of it's still talking about x over 4. And it actually stands for because the negative 4 value is actually less than s, but it's less than 4. If you look at the x value here, at x point, breaking down the different values you are being given, your x value will always surely be less than what? Less than 4.